In today's video, we are going to discuss all the first launches. Relativity Space is ready. Welcome to our YouTube channel, The Globe Facade. So stick right to the video and don't miss any portions. Also, if you are new to the channel, remember to subscribe and hit the bell icon so you won't miss any future videos we upload. New companies following and SpaceX's whack aren't coming up and are on the path to making the next jump in launching their rockets. One of the most important of these is Relativity Space, and we have to tell you about their upcoming launch attempt. Relativity Space is presently one of the most valuable and well-funded private aircraft companies in recent history, trailing only behind Elon Musk's SpaceX, which raised $7 billion in less than 10 years. Relativity's rock and production facility for the first 3D printed launch rocket is located in Long Beach, California, near a machine called Stargate, as the world's largest 3D printer, and it was designed to create spacefaring rockets, not less capable than anything SpaceX would have broken plans to launch. As going to be the Terran 1 rocket, the launch date has not been confirmed yet, but it's expected to take place this year. The rocket itself, the Terran 1, is a two-stage, 3D printed disposable small lift to launch vehicle that has been in development since 2017. Terran 1 is divided into two stages. The French stage is propelled by 9 Neon 1 engines, each of which produces 23,000 pounds or 100 kilonewtons of thrust while consuming methane and oxygen propellants in a gas generator cycle. The second stage is propelled by a single Aeon 1 vacuum optimized variant called the On-Back, which produces 28,300 pounds or 126 kilonewtons of force in a vacuum. Rocket can carry up to 500 kilograms or 300 pounds to low Earth orbit. However, the company often claims a payload capacity of 250 kilograms or 760 pounds. Terran 1's primary and secondary structures are made of a special aluminum alloy using Relativity Stargate 3D printer. Relativity says that they can reduce the part count in the vehicle by multitudes compared to traditionally manufactured rockets and produce a whole flight article from raw materials in 60 days, which accounts for 90% of Terran 1's mass. Terran R, which is related to Terran 1, will employ the same kind of tooling as Terran 1 due to its advantages. The company picked 3D printing for a very clear reason. Many other industries have adopted automation and software-driven technologies, CEO Tim Ellis said. That's all I see 3D printing as being. It's just an automation technology that merges many parts. So our goal is to have 100 times fewer parts for rockets. Tim Ellis compared Relativity's tactics to the early days of the space industry. The same fundamental premise of aerospace has been unchanged since back when we started in Apollo. He clarified it's still just as true today, as it was 60 years ago that we were building products, one at a time by hand in these giant factories full of mixed tooling, with hundreds of thousands to millions of individual parts, all assembled with a bunch of manual labor across a very complicated supply chain. 3D printing simplifies the supply chain to the point that our entire launch vehicle is made of only 4 basic metals. This is in addition to the fact that the approach enables the corporation to quickly change as its rockets evolved. Relativity is far from the only aerospace company to employ 3D printing technologies. Companies such as SpaceX, Boeing and Blue Origin have integrated 3D printed parts in very specific areas. CEO Tim Ellis himself assisted in the development of Blue Origin's 3D printing capabilities during his time working there. However, the company's 3D printing capabilities are one of a kind. Josh Brost, Relativity's Vice President of Business Development, walked journalists from space. Come around the company's California headquarters and printing factory during a 2021 hour during the Tour. Bros demonstrated a Terran, our rocket that was 3D printed. The company expects that this automation will simplify and improve the rocket building process, with more aerospace companies aiming to launch their satellite constellations, developing technology, and other projects. The need for launch vehicles is increasing rapidly according to Grosthairs. This feeling in the industry that there is not enough affordable, reliable, timely launch capacity in the market to serve what everybody wants to do, Prost said. That's right, significant cost cutting was the most important and biggest motivator towards using a 3D printing process for manufacturing. After that, cutting the production time is Relativity Space's primary motive. The normal rocket takes on the order of 2 years to build when you factor in long lead hardware that they need to buy. Rost further explained, we're working to be able to go from raw materials in the door to a launch vehicle leaving the door in 60 days. Relativity Space is quickly growing with roughly 600 employees. It has a presence at the Cape Canaveral Space Force Station cases where it is building Launch Complex 16 LC-16 for both Terran and Terran, 1 Cape Canaveral. As you may know, as where many of SpaceX's launches have taken place, the Terran 1 will launch from Cape Canaveral Turtle. This is in addition to the company's headquarters and manufacturing facilities in Long Beach, California. NASA has selected Relativity Space as one of the 12 companies to provide launch services for the agency's future class acquisition of dedicated and ride-share farm mission, which will be for orbital supply missions when it launches. Terran 1's launch will mark the world's first of an entirely 3D printed rocket. Previous delays have pushed the date from 2021 to 2022. The company confirmed the new schedule on Twitter as well as confirmed that the launch will take place from Cape Canaveral, Florida. The delay came just 2 months after Relativity announced that the Terran 1 would launch in the winter of 2021. Nonetheless, Relativity Stick has garnered quite a lot of interest from investors, so much that its valuation vaulted to $2 billion after a $650 million funding round in summer 2021. The first flight will be launched with the mission name Good Luck, Have Fun, and will carry no payload by 2022. 6 flights total are planned, and one of those launches will involve putting a cubist into orbit as part of a deal with NASA in June 2022. Just like SpaceX, the eventual end goal for Relativity Space seems to be colonization and settlement of Mars. Relativity hopes to go beyond low Earth orbit and land the first internally 3D printed rocket on Mars. The company's most ambitious plan is to put 3D printers on Mars, the Moon, and other off-world colonies to help develop the infrastructure required to sustain human life on those bodies. For the time being, there is still widespread pessimism about the endurance of a huge 3D printed building, let alone rocketry to accelerate testing efforts and accomplish a prompt Mars landing. The company needs to increase its ties with seasoned aerospace sector players, both public and private. Relativity Space can get ahead by putting prototypes under pressure, and often much in the same way SpaceX does. This seems to be their plan for the time being. As noted from the planned test schedules of the Terran 1, the company itself has been quite instrumental in the development of 3D printing for rocketry. We know we risk sounding redundant, but the restatement is important because aerospace production is one of the most strictly regulated industries in the world, and it has taken several years for the various safety and certification bodies to conduct their testing and formulate rules for the use of 3D printed parts. This will result in significant growth in the 3D printing market for high durability polymers, resins, and metal 3D printing materials. The Veneration Aviation Administration of the United States has only recently revealed its intention for testing and developing criteria for 3D printing parts. Thus, these kinds of new laws will define 3D printing demand in the aerospace industry in the next year. Eventually 3D printers will be able to produce durable 3D printed metal parts, which may seem strange to some of you. The truth, however, is that metal 3D printing is not new, but it has only been limited to lighter and slightly less robust metals such as aluminium. No narrow space giant Boeing has been a leading user the 3D printing parts for over a decade. So it's not unexpected that they've pushed for the development of a new titanium 3D printing technique. Titanium is the strongest metal now accessible for 3D printing. Therefore, this innovation will open a whole new world of possibilities for directly manufacturing larger and more essential parts with 3D printing. Sometimes the best way to keep track or be notified of fruitful innovations in the airspace industry is to follow the aircraft manufacturing industry, as the two are related. In any case, Relativity Space's tests will be instrumental in unfolding this new era. Further, YouTube is now recommending some of our other videos for you to watch. Thank you for watching this video. I enjoy making videos. If you enjoyed this video, please subscribe, leave a comment and turn on the notification bell to receive notifications of new videos and music. Thanks.